Hi, I'm Dorian Dyer Westacott from company Lima, and we made a video wall. Our project has three main components. We've got on the server, we're running the main frame buffer for the video wall is stored in a VNC server on a computer. And we've written our own application called a VNC splitter, which takes the updates from the VNC server and splits them up into the relevant rectangles for each screen, then sends those rectangles over Ethernet to the correct DE2 board, which drives the monitor. We also wrote some configuration and applications and interfaces, which allow the developer to create an application which can run across all monitors and know where each monitor is in the layout. The DE2 board receives updates from Ethernet. It decodes these and stores them in the frame buffer in DRAM, and then drives the display module, which outputs the VGA. One of the problems we had with this setup was that our 8 megabytes of DRAM is only single-ported, meaning that we're unable to write updates to it in between the reading from it for driving our VGA module. It's simply, the hardware is not fast enough to do this. So to solve this, we took the quarter resolution of the monitor, and which gave us plenty of time between reads to write updates. We also wanted our project to allow arbitrary monitor layouts. So this 2D would be very easy to implement, just a rectangular grid. But we wanted to allow different sized monitors and even gaps between monitors. To facilitate this, we created a 2D array the same size as the large frame buffer, with each pixel in this array containing a reference to an instance of the monitor class. That instance then has the methods needed to send an update to a DE2 board. So when an update rectangle comes in from the VNC server, all you have to do is search through the pixels in that rectangle, and you can find which monitors you need to update. Obviously, this can be used to create a large display out of many smaller displays, but the software we provided allows a much wider range of uses, including oddly shaped monitor arrangements. If you were, for example, a museum owner and you wanted to create an exhibit, you could have a large monitor for a video, some monitors on the side to display data about your exhibit, and then maybe some interactive monitors at the bottom that allow the visitor to the museum to interact with this. With our interfaces and software, it's very easy to set all this up, and it all can be driven from one computer, and so you won't have any problems with synchronization that you might if each of these were a separate computer. We also think there are great applications for this video wall in advertising. If you owned an electronics store, you would already have a video wall because you would have all these displays which you're trying to sell. Then, as the owner of this electronics store, you could sell off portions of your video wall to advertisers and let them advertise their products in store, so that when someone is browsing the store looking for something to buy, they'll look over, see the video wall, say, "Oh wow, I want to buy that product." Lastly, this allows you to drive monitors over Ethernet. VGA isn't able to extend as long as an Ethernet cable without many repeaters, and you're likely even to already have an Ethernet network set up in where you might want to have this monitor. This allows you to have the server a long way away from where you'd like to display. Thank you. I hope you had a chance to play Asteroids upstairs across 7 displays.